Recently, the Microsoft Purview team released a preview of data lineage extraction for Azure SQL Database. So in this video, we're going to check out what it is and how to get started. I'm Brian Hitney, a cloud solution architect focused on data and analytics. So data lineage is a key component of any data governance solution. What exactly is data lineage? Why is it complicated, and how do we get started using this feature? Well, let's take a look. So every piece of data that we have in our organization has a life cycle to it. And while sometimes this life cycle can be fairly simple, it's usually very complex. And it's complex because our systems are seldom homogeneous. So we need to move data between different systems. We also have to transform that data as it moves from one system to another. And oftentimes that data flow is not linear, so that adds further complication. So we need to solve this problem a number of different ways, and we can do that through built-in capabilities. We can do that through extensibility like the Apache Atlas API or through platforms like Open Lineage. In this case, we're going to look at one of the tools to help solve that, which is extracting that information dynamically from Azure SQL Database stored procedures. Let's take a look. First, some basic setup. You can try this yourself with the code that is in the Purview lab at aka.ms/purviewlab. I've got my Azure SQL Database where I am the administrator using my Azure AD account, and I've connected Purview to Azure SQL DB using Purview's managed identity. And the name of my Purview account is just called Purview Example. In the SQL Server, we've created a master key. If one does not already exist, you'll need to have that. And then I've created a user given the same name as the Purview account, in this case Purview Example, created from an external provider, and then added that user to the DB owner role. We need DB owner because the scanning engine is going to look dynamically at the run history of these stored procedures in order to determine lineage. So this way, if we have branching logic, dynamic SQL, or other factors, we're still able to gather lineage. I've taken a sample database created in the lab and added some very simple schema in order to test this out. We have a source test table that has a first name and last name column. We can see that also listed over here on the left. We've added a few rows to it, Bob Smith, Mike Jones, etc., that you could see listed here. And then we added a number of destination test tables, and we created several in order to see what happens with a straight copy of that data, which would be destination test, where we've got the source ID, first name and last name. But then we also wanted to test a conditional situation where we may branch based off of, in this case, we're just going to check whether or not the ID is even or odd, and then decide where we want to put that data. So we have destination test even and odd. And then the procedures in order to carry out that. So we have move data test, which will just copy it directly into the destination test, and then also branch, which will copy the data into the right table based off of whether or not the user ID is an even or odd value. So down below, we could see what is in those tables right now. Just a few sample rows. This would be the destination test, the first section here. And then we have in the middle our even, and at the bottom, we have our odd. The last condition we'd like to test is if we do some kind of transformation. And so we've created a schema just called destination combo, where we'll look at capturing the whole name instead of the first name and last name separately. So when we move that combo, when we call move data combo, we'll insert the whole name, which is just a concatenation of the first and last name. And you can see what that looks like here, where we take that source ID and first and last name and combine it. Here, Bob Smith, Mike Jones. So that would basically show what a simple transformation might look like. Here in my Purview data map, I already have the data source configured, and if I wanted to set up a new scan, I'll just click the new scan button. By default, it will have lineage extraction set to enabled and will list the criteria you need to have in order to extract that lineage from an Azure SQL database. Now, in this case, if I select my database name, you'll see that it will turn off. And that's because I already have a scan that extracts lineage, and we can only have one scan that extracts lineage per data source. So I'll click cancel. And if we view details, we'll see that that scan Lineage has run recently, and I can see all of the scans by clicking on Scans and clicking the scan, which is Scan Lineage. When we set up a Lineage scan, it's actually going to configure two different scans. One is our static analysis, which is the scan that we configured to scan our entire database. And then the Lineage extraction, which is a separate scan, which will run automatically every 6 hours. And this is true even if you have the scan set up to run only once. So for a development environment, you might want to delete this scan when not needed, particularly if your database is set to spin down when not needed. Now let's go over to the data catalog and take a look. Here in the data catalog, I'll click Browse Assets to view all of the assets here in my Contoso collection. And I can further refine this a number of ways by clicking tables or stored procedures. Now I happen to name everything with test, so we can just do a search for test and it will limit this to all of the objects that we've been talking about. So we can see that we have the stored procedures, which are processes that will move or copy the data rather to our destination tables. And then we also have source test, which is the table we want to look at. So I will click on it. And here we can look at the properties, or in this case, the schema, verify that we have our first name and last name and an ID. And then finally click on Lineage, where we can see that we have our source test table. All the way on the right side, we have the destination tables and our three stored procedures that will copy the data. One that will move it into our destination test, the other one which has that branching logic that can copy it depending on whether or not the ID is even or odd. And then finally, the one that will concatenate the data, the first and last name, into a single column. One thing to keep in mind is that we need execution of the stored procedures after we configured the Lineage extraction scan in order for Purview to pick up this Lineage. So if you aren't seeing the Lineage, make sure that the stored procedures have had at least one execution after the scans have been configured. So let's focus on the combo that does the concatenation of the first name and last name into the destination test combo table. Now, if we look at this, this won't have any schema associated with it because it is a process. But the other thing to note here is right now we do not have column level data to show. So we don't see that the first and last name is concatenated into the whole name here in the destination test combo table. However, that information is actually there. If we click on properties, look at the runs, and we'll click properties once more and look at the column mapping property. We'll see that in the column mapping property, we have several source and sync. So looking at the source, we could see that we have the first name from the source with a sync of whole name, and same with the source of last name with a sync of whole name. So the data is there, and I think it's just a matter of time until we see it integrated into the UI. So that's a quick look at dynamic lineage extraction from Azure SQL Database stored procedures. For more info, check out the Purview lab, and specifically this content is documented in module 15. What do you think? Questions or comments? Let us know.